P4 Tong primary school term 2 review. So this one is actually for let me write it. The week P4 week 19 2026 practice. So I'm going to the first question. Okay, question 1. What fraction of the shapes in the box are halves? So you can see that actually there's 1, 2, 3, 4. So that means if I want the hearts, I know that I have 4. But you know that when you express as a fraction, you need the denominator to be the total number of items. So over here, we have 4 hearts out of how many shapes? I'm sorry, how many shapes altogether? And when we count 3, 6, 9, 12, we have 12 shapes in total. So in order to express as a fraction, it means that it must be the heart over the total. So it would be 4 over 12. But always remember, this fraction, you have to always simplify it. Even when they never say it, you still have to simplify. So 4/12, you can divide by 4. This is also divided by 4. Your answer will be 1/3. So you just write down your final answer in the blank. Question number 2. Write 9 over 4 as a mixed number. So 9 over 4 is the same thing as 9 divided by 4. So if you look at your denominator, depending on the denominator, you can express one whole out of it. So over here, the denominator is a 4. So which means one whole is equal to 4 quarters, which is 4 over 4. So 9 over 4, how many wholes can you get out of 9 over 4? So actually, if you want, you can do the long division, 9 divided by 4. So 9 divided by 4, nearest is 2 groups, minus 8, 1. So you cannot write remainder 1 here. In order to express as a mixed number, this will be your whole number. And this remainder will be your numerator. So that means what is 9 over 4 as a mixed number? It will be 2 wholes. Numerator is 1 out of denominator follow 4. So the answer is 2 and 1 quarter. If I want to write this, 4 over 4 is 1 whole. Another 1 whole is also 4 over 4. Over here, we have 2 wholes already. It makes 8 over 4. So 8 over 4, there's a remainder of another 1 quarter. So here, 1 plus 1 plus 1 quarter, you will get 2 and 1 quarter as well. It's the same here. Okay. Question number, sorry, scroll down. Question number 3. 7 wholes by 6 is equal to something over 6. So which means that this will be an improper fraction. So what's the missing number in the box? So it means there'll be 7 wholes of 6 over 6. Already say, depending on your denominator, you express 1 whole out. 1 whole will be, guys, 1 whole equals to 6, 6. So here I got 7 wholes. So that means it will be 7 times 6 over 6. 7 of this, okay? And plus another 5 over 6. So 7 over 6 will be 42 over 6 plus 5 over 6. Answer 42 plus 5, 47 over 6. So I only want the missing number. Do not write the fraction out. You just write the answer, 47. Okay. So it's the same thing. 1 whole is 6 over 6, right? Here we have 7 wholes. You become 7. So 6 over 6 will be, these 6 parts, we will have 7 groups of 6, which is why I will end up with this one. Okay? So that's how it works. Okay, question number 4. I want to name the angle that is 60 degrees. So if you look at your protractor, you need to see which one is 60 degrees. From here, we actually can see that it is A or B, A or C. You can see that we are reading from the outer scale. If you go all the way up, this AOC is 120. Okay, angle AOC is 120 degrees, which is not what I want. So if I were to look at the other angle, which is here, BOC, here, let me highlight the letters, BOC. Do you think it is 60 degrees? You read. Look at the line here. The baseline is actually touching the zero in the inner scale. So we're going to read all the way up to here. Yes, this is 60 degrees. So that means what's your answer? Angle BOC is 60 degrees. Or some of you actually don't write BOC. Some of you write COB. Angle COB is also 60 degrees. Whichever you want to write also can. So actually for me, I write COB. I read from the top to bottom. Okay. Question number 5. Oh, measure angle Y as as with a protractor. So over here, I don't have a protractor to show you, but please approach your teacher, okay, if you're not very sure, that the answer should be 123 degrees. This angle here, it must be 123 degrees when you measure with a protractor. Okay. Question number 6. What is the value of 38 plus 5, 6? Express your answer as a mixed number. So I'm going to write out my equation, 38 plus 5, 6. So if you look at the denominators, they are actually not the same. So when we do fractions, we always change the denominator to the same denominator. So 8 and 6, if your multiplication is very good, you should know that both will be changed to a denominator of 24. So this one times 3 times 3. This times 4. So you express a fraction again, you write it out. 3 times 3 is 9 over 24 plus 5 times 4 will be 20 over 24. 9 plus 20, 29 over 24. So over here, this is improper. I need it in mixed number. So mixed number, one whole depending on your denominator, express it out. This is 24, which means one whole equals to 24 over 24. But we have 29, which means there's another remaining of 5 over 24. So your mixed number will be one whole 5 over 24. This is already simplified. There is no way to simplify it further. So your answer will be one whole 5 over 24. Question 7. What is the mixed number represented by A in the number line? Give your answer in the simplest form. So if you look at from here, number 2 to number 3, you have a few intervals in between them. And if you calculate, it's actually 1, 2, 3, 4, 5, 6, 7, 8 intervals, which means from number 2 to number 3 is a difference of just 1. Okay, so from here to here is plus 1, one whole only. The difference is 1. But if you look at in the middle, and in this one whole, it is cut into 8 intervals, which means that one single reading here is a plus 1, 8. Okay, this is plus 1, 8. Then after that, plus another 1, 8, all the way to 8. So if you look at A, is actually down here. So it's how many 8s? So it's 1, 2, 3, 4, 5, 6. So this will be a fraction of 6 over 8. So over here is 2 wholes and the fraction 6 over 8. But this is not my final answer. I need simplest form, which means I need to divide by 2. This number 6 and 8 can be divided by 2. So it'll be 2 wholes, 3 quarter. This is your answer. Okay? Because this one is 2 wholes already. So you plus another from here to here is 6 over 8. So 2 wholes plus 6 over 8, you get 2 wholes 6 over 8. And then after that, you simplify, you get 2 and 3 quarter. Okay? Question 8, arrange the fractions in increasing order. Increasing means from smallest to greatest. So this is mixed number, this is improper, and this is improper. So in order to compare it clearly, right? For me, I will always express it as a mixed number. So 11 over 7 is actually 1 whole 4 over 7. Because 7 over 7 plus 4 over 7 is 11 over 7. So it will be 1 whole 4 over 7 8 over 3 will be 2 wholes and 2 thirds. Okay, because 3 over 3 is 1 whole. Another 3 over 3, another whole. So it's 2 wholes and then there's a remainder of 2 thirds. So if you look at all these fractions in mixed number, we can actually arrange them in the sense that it is in increasing order. Increasing means from smallest to greatest. So needless to say, the very smallest one will be 1 whole 4 over 7, which is always write the original value given, 11 over 7. And these two wholes 2 7 and 2 wholes 2 third. Which one is actually smaller? It is 2 wholes 2 over 7. Because 2 wholes is equal, but if you compare 2 over 7 and 2 third, right? 2 over 7 is actually a smaller portion than 2 third. Because 2 third is very, very close to 1 whole already. Okay? So that is why 2 wholes 2 over 7 is smaller than 2 whole 2 third. So the last one will be 8 over 3. I always write the original value given. Okay? Next, question 9. Okay, use the table below to answer questions 9 and 10. The table shows the number of students in different clubs. Complete the table below. So this is badminton, swimming, and total. And we have the number of girls in this column, number of boys, and the total number of children. Okay, so if we were to look at this, we can actually find out what is A, what is C, what is B, and D. So from here, let's work out the number of girls in badminton. I don't know how many, but in swimming, we have 50. Total girls is 90. So for A, we have to take 90 minus 50. This is 40. 40 girls are in the badminton club. Now for the boys, C here, right? So we work out C first. So the number of boys, badminton club is 75. I don't know how many for swimming, but I know I have 160 boys. So in order to find the boys in the swimming club, I have to take 160 minus 75. So the boys in the swimming club is 85. Now we can tally up the total. So 40 girls, 75 boys. How many children in badminton club in total? So this is for B. It will be 40 plus 75. 115. So we write 115 here. Then D will be the number of children in swimming club only. So it will be 50 plus 85. 135. So we will fill up the table. Question 10. When some boys left swimming club, the number of students in both clubs became the same. How many boys remained in the swimming club in the end? So you can see that the total number of children, right? It would be 115 here, 135 here. Okay, the number of students in both class must be the same. So what is the difference between them? So between badminton and swimming, right, there's a difference of 135 minus 115, 20 students. So the difference between the badminton club and swimming club, right, the total number of children is 20 students. So that means, right, how many boys remain in the swimming club? So only people left the swimming club. So which means, right, these 20 students will be 20 boys. The 20 boys left the swimming club. Only the boys leave. None of the girls leave. So you know that the swimming club, there are actually 85 boys. Now 20 students leave, which are the boys. So how many boys remained? 85 minus 20. Your answer is 65 boys. So remember to fill the final answer in the blank given. 65 boys. Question 11, section B. A shop had 7 kg of strawberries. 1/4 kg of strawberries was sold in the morning. Another 3/5 kg of strawberries was sold in the afternoon. A, what was the total mass of strawberries sold? Okay, we do A first. Later, then we work out B. So they're asking for the total mass of strawberries sold. We know 1/4 was sold in the morning. 3/5 kg sold in the afternoon. So we have to add these two fractions together. 1/4 plus 3/5. Because these are the fractions of strawberries sold in the morning and afternoon together. So if you look at the denominator, you need to make them to the same denominator of 20 because 4 and 5, lowest common multiple is 20. So this one times 5 times 5. This one times 4 times 4. So this will convert to 5 over 20 plus 12 over 20. 5 plus 12, 17 over 20. So you know that this is already in simplified form. You cannot simplify further. So the answer will be 7 over 20 kg for A. And B, once you found answer A, you can do question B. Question B says, what was the mass of strawberries that were left unsold? Remember how many kg did the shop have? The shop has 7 kg at first. So the shop is only selling 17 over 20 kg of strawberries. So I have to subtract the whole number 7 minus 17 over 20 equals to, so I'm going to express this into a mixed fraction because we're subtracting a fraction here. So we cannot just take 7 wholes like that. We have to express 7 wholes into a fraction, a mixed number. So 7 wholes, I'm going to split. I take 1 whole out, I'm left with 6 wholes. Why do I take 1 whole out? So that I can express that 1 whole into a fraction of the whole, which is 20 over 20. Depending on your denominator, the whole, the fraction for that whole follows. So the denominator is 20. That means 1 whole will be 20 out of 20. Okay, so if you express 7 wholes as a mixed number, it will be 6 wholes, 20 over 20, minus away whatever is sold, 17 over 20. Answer, 6 wholes, please remember to write down. 20 minus 17 is 3 over 20. Simplified fraction already, so we cannot simplify further. So the answer is 6 wholes, 3 over 20. Sorry, this one right properly. 3 over 20. Let I write again. Okay, that's your answer. Question number 12. Okay, there are 72 apples and oranges in a box. 79 of the fruits are apples and the rest are oranges. How many apples are there? So over here, we are going to calculate. There are two parts of the question, A and B. So we calculate A. Some of you can actually see very clearly that we have 9 units. But if you cannot see, I would suggest you draw out. 72 apples will be the total number of fruits. And we have 79 apples. So I'm going to cut into 7 parts. Cut this 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 9 parts. I'm sorry. I'm cutting into 9 parts. And the 7 units that we have out of 9, these 7 units will be apples. And we know the total number of fruits we have altogether is 72. So I want to find how many apples. When we see this model, right, we can actually use units to help us. So you can see 9 units is a total of 72. Look for 1 unit, 72 divided by 9. 1 unit is 8. I want apples. Apples is 1, 2, 3, 4, 5, 6, 7 units. So 7 times 8. 56. So we have 56 apples. Out of 72 fruits, 56 are apples. So question number B is asking me, how many more apples than oranges are there? So we know that if these are apples, definitely whatever is left not labeled will be oranges. If you look at the difference between the number of apples and number of oranges in units, it is actually a difference of 7 minus 2. 7 unit minus 2 unit equals to 5 units. So how many more apples and oranges are there? Apples got 7 units. I write again. Oranges 2 units. How many more? Looking at difference. That's why I take 7u minus 2u. The difference in units between apples and oranges is 5 units. So I'm looking at the value of 5 units. We already worked out what is 1 unit here. 1 unit is the value of 8. So 5 units will be 5 times 8. Your answer is 40. There are 40 more apples than oranges. So 40 more apples. You can just write 40 more. Okay. Question number 13. Sorry, let me adjust. Okay, question 13. The line graph below shows the number of buns in the shop over 5 weeks. So these are the number of buns and these are the number of weeks. So before we do anything for graphs, be it bar graphs, picture graphs, line graphs, okay, we have to write down the values for each of them so that we will not make careless mistakes. So week 1, if you look carefully, from 0 to 50, there are 5 readings, which means that each reading represents a value of 10. So here is 100, 110, 20, 30, 40. So week 1 is 140. Week 2, exactly 250. Week 3 is 1 up 150, this is 160. Week 4 is 1 down 100, which is 90. And week 5 is 200 here, so plus 10, 210. So with all the values, we will be able to work out our answer. Question A asking us, let me zoom out a little. Okay. Question A is asking us, in which week did the shop sell the most number of buns? So which week is the highest value? Is none other than week 2. You can see from the graph here. Question number B, which 1 week period shows the greatest decrease in the number of buns sold? So when you look at your graph, decrease means when the line graph goes down. So there's a decrease here, and there's another decrease here. So we need to see which 1 week period shows the greatest decrease. So from week 2 to week 3, okay, week 2 to week 3, we can see that there's a difference. 250, it drops to 160. So it is actually a difference of how many buns. So we calculate 250 minus 160. Week 2 to week 3 is 90 decrease. But now from week 3 to week 4, there's another decrease. So let's calculate. Week 3 to week 4, from 160, it falls even more to 90. So the difference will be 160 minus 90 equals to 70. So, sorry, let me write this again. So equals, so this is 70. So which 1 week period show the greatest decrease? Is it week 2 to week 3 or week 3 to week 4? The answer is week 2 to week 3 because it is 90 lesser, whereas week 3 to week 4 is 70 lesser. Question C, how many more buns were sold in week 5 than week 1? So if you look at the graph, week 5, it is 210. Week 1 is 140. So I need to find the difference between week 5 and week 1. So we just take 210 minus 140. Your answer is 70 more buns. So just write 70 more buns as your answer. Question number 14. I think I'll zoom in a little. Okay. In a shop, there were 4 times as many t-shirts as dresses at first. 1,053 t-shirts and 138 dresses were sold. There was an equal number of t-shirts and dresses left. A says each dress is $25. How much did the shop collect from the sale of the dresses? So we have to calculate for A first because A is very straightforward. For B, then we will be able to draw a model. So over here, it says one dress is $25. So I write 1D, represent one dress, $25. But in your question, it says that there were 138 dresses sold. So I need to find how much was collected from the sale of the dresses. So 138 times $25. You will get the answer, $3,450. So the unit is given, just fill up 3,450. Question B, how many t-shirts were in the shop at first? So for this, right, let me zoom out. For this, you have to draw a model. Because if you were to read the question again, you know that this shop has 4 times as many t-shirts as dresses. So t-shirt, dress, t-shirt 4 times. I'm going to draw 4 units. Dress is just 1 unit. So you're going to sell 1053 t-shirts and 138 dresses. Then equal number of t-shirts and dresses left. So in order to make sure that the leftover model is equal, right? You ask yourself, where can I shade away? So you know that dresses is only 138 sold, whereby shirts is 1053. So in order to make them equal, it is only this part that is the common unit. So we cannot cut anywhere else. So the dresses, 138. So that means there will be equal number of t-shirts and dresses left, which means this will be whatever t-shirts are sold, which is 1053. So we can see from here there is a difference of 3U. Sorry, this one is not accurate. This is 3U. So we can find the value of 3 units by taking 1053 minus 138, which is 915. Look for 1 unit, 915 divided by 3, 305. But my question asked me for how many t-shirts in the shop at first. We know there were 4 times as many t-shirts as dresses. So which means the t-shirts actually has 4 units. So I'm going to look for the value of 4 units by taking 4 times 305. Answer 1220. So the answer will be how many t-shirts were in the shop at first? It is 1,220 t-shirts. And this is your end of the paper, end of the question and end of the paper.